All right, we're going to finish up the law of sines lesson today, and this is just adding another aspect to it, which is finding the area of an oblique triangle. So this is going to be lesson 6.1b, area of an oblique triangle. So this is another lesson that might help you on the ACT. Let's just talk about a triangle in general. Alright, so here's an oblique triangle, a triangle that doesn't have a right angle. We'll say this is angle A, B, C. Now, normally, whenever we're finding the area of a triangle, like our original formula back from geometry, a triangle is 1/2. The area of a triangle is 1/2 base times the height. Alright, so let's take this triangle in particular. If I labeled the sides according to their angles, it would be labeled this way. Alright, so for this triangle, if I'm going to bring an altitude down, where that's a right angle, that's going to be the height of the triangle. The way I've brought that altitude down, the base is going to be this side, which is side C. Alright, and then if I wanted to represent that height, I could use right triangle trigonometry, where the height, if we're comparing it to angle A, the height would be, or what we have is, let me just draw it with another color. We have a right triangle that we formed right here. And for that little right triangle, the height is going to be opposite of angle A, and B is going to be the hypotenuse. So we could say that the sine of angle A is equal to the height over B. That's the opposite. If we're just looking at the little green triangle, green right triangle, the opposite over the hypotenuse. Now we want to represent height, because that's what we're filling in. So we would, to find the height, we would just multiply by B. All right, so we can represent the height of that triangle as B sine of A. And that actually just gave us our new area formula. It's going to be 1/2 B times C times sine of A. Now, depending on what you're given in the triangle, we can kind of change this up. So as long as the two sides don't match the same letter as your angle, we can rearrange this. So it can also be 1/2 AB times sine of C. It also can be 1/2 AC times sine of B. So you just look at what you're given. The two sides don't need to match the angle. All right, so let's look at example 1. We're going to find the area of a triangular lot containing side lengths 84 yards and 55 yards. And form an angle of 115 degrees. degrees. Okay, so I'm just going to jot down a diagram of this triangular lot. Okay, so I know I have a side length of 55 yards and a side length of 84 yards. And then in between those, I have an angle of 115 degrees. And so what I'm looking for is the area. So I'm just going to use my new area formula we just wrote down. It's going to be 1/2. So as long as neither one of those sides are opposite of the angle, we can use the formula. So they're the sides surrounding the angle. So we just multiply them together and then multiply by the sine of the angle. So on the challenge exam, it will either just be left like that, or it's possible that you can use your little calculator to multiply 1/2 times 55 times 84 and get 2,310 and just leave it like this. And then it would be square yards. And that's it. That's the new formula for today. So you might have to draw a diagram. It might be drawn for you, but